Hi everyone, welcome back to the channel. This is Asim here. Hope you liked the previous video where we made the local recon machine so that if you can't afford a VPS, you could use your local machine to do recon on whatever targets you want and get the subdomains and other sensitive files on your system as well. So in this video, we are going to continue with Be the Hacker series and we are going to talk about SSRF, which is like a critical bug in most of the cases. So it's like P0, P1 kind of thing in most of the cases. So yeah, it's not a very difficult thing to exploit. The only difficulty lies is how hard you try to find this out. So it's a very simple bug. So we're going to talk about it in detail, and we're going to also see one of the popular services getting exploited by this. That's Google. So let's start with this. So SSRF, as you all know, it's server-side request forgery. What, why, and how. So the overview of this video. First, we'll talk about what is SSRF, then the types of SSRF, and then we are gonna see a practical hands-on on a Forgery lab, and then I'm gonna explain you SSRF in Google that happened. So that's a report. That's a nicely written report. So you could see on the left side, so there's this attacker which has a like overcoat and a hat, and his traffic is being passed through a firewall which is port 80, port 443, which these two ports are allowed. Then there's this green thing, that's the web application. So the web application is vulnerable to SSRF, and due to that the attacker's traffic is being passed to other backend services like Elasticsearch, Kibana, Memcache, Redis, MongoDB. So if you don't know what these are basically services that any other company uses for a lot of things. So these are sensitive services and are not exposed to the public internet. So these are accessible internal to the network, and through SSRF an attacker could get access to these. So you would have known that, or you would have seen that, like the public networks are where the companies try to focus more, so that whatever is that's exposed online, they try to limit the exposure online as well as do a strong scrutiny on that. Whereas internal networks are not protected very strongly because it's assumed that the if like it's protected because it's internal. So SSRF allows you to access that internal network. So let's see what's an SSRF. So the definition says that it allows an attacker to induce server-side application to send HTTP request to the attacker's choosing. So if the attacker chooses to send the request to their domain, so the backend server would be sending request to that. You might think that what's the big deal, right? Sending a get or post request to any of my own services, why would that be an issue, right? So actually it becomes an issue when the attacker is able to access the internal network through the internal services, because internal services, they trust each other in most of the cases. There's a trust relationship, or if they are on the same subnetwork or subnet, so then they can access each other. You cannot do that from the outside network because the outside connection is very limited. Whereas if you get a SSRF, so due to SSRF you could access the internal network, and since you're able to access the internal network, so you could do internal port scanning, or you could access some maybe admin panel which is open to the local host, so which can only be accessed through localhost or through the internal subnet, so you can do that as well. So that's where its impact increases. So you'll see in this next slide. So if you see on the right, so there are some of the case scenarios that I'm going to talk about. So the right diagram explains that. So let me come to that as well. Authorized access or access to data within the network. So as I already told that the private networks are not very strongly protected. And since SSRF allows you to access the private internal network, so you could have unauthorized access to that. In the Portsugar lab also, we would see how we are able to access the internal admin lab or internal admin portal through this SSRF bug. In some cases, this might lead to arbitrary command execution. Connections to external third-party systems might result in malicious onward attacks that appear to originate from the organization. So if you see the diagram on the right, you could see this victim's vulnerable server, and then there's this arrow which is pointing third-party public server. So suppose you find an SSRF on Google, and then you are basically able to send requests through Google server wherever you want, right? So you could use that to port scan the internal services. That's the first point here, unauthorized action or access to data within the organization. You could also use that server to do port scan or do ping scan on other companies' network, right? So if you're doing that in like that would have a very bad reputation on the part of whatever organization you have hacked. So if this was the case on Google, so that would have a very bad reputation against Google. Moreover, in some cases, it's also illegal to do port scanning, so that also might have some legal issues there. So let's talk about what are the types of SSRF. So there's this basic SSRF where you like the response is being displayed to the attacker, and then there's this blind SSRF, which is the response is not displayed. So in some of the cases, what happens is that you have SSRF on the internal web application, but the outbound traffic is limited. So like the internal server is not allowed to access the public internet. So if in that case you try to access your website or your web server through the internal SSRF attack, so like suppose you have done the SSRF and you're trying to access your website or you're trying to download some payload from your server to that particular instance which you have compromised. So that might not be the case because the internal server might not be able to access the public internet. So there that comes under the blind SSRF. So for that you could use burp collaborator. So there you see the DNS request being made for that collaborator URL as well. So that helps you identify, okay, there's this SSRF, but that's being limited. So people have been using like DNS exfiltration and other kinds of things for that, but we are not gonna talk about those things here. There's this SSRF payload list and payload all things and like other payloads as well. This is a very exhaustive list. You would find a lot of payloads, a lot of bypasses. So if you have not been able to like do SSRF due to one particular exploit being blocked, you could use some other things like if the HTTP protocol is blocked, you could use file protocol or gopher protocol. So in most of the cases, these are not bypassed, like these are not restricted. Now let's start with the lab. So we'll be doing this basic SSRF against the local server. Let me come to this. So is the lab. I've already logged into the account. The lab says the lab has a stock check feature which fetches data from an internal system. To solve the lab, change the stock check URL to access the admin interface at http localhost admin and delete the user Carlos. So we have to access the internal host, that is admin panel, which is on the localhost, and delete the user Carlos. So let's open my burp suite first. So I use an add-on Foxy proxy to quickly switch between different proxies. It's available for Chrome as well as Firefox. Like you could see it. So here it is. So I have burp, so I could just click on burp and I would be able to switch on that. So let's do that already. Burp. You could use burp community version. It's good. Like you could do this using that also. Now let's see the application. We like to shop. Here are the details for this. We're waiting for burp to start. Okay, now burp has been started. Go to the proxy, switch the intercept off. Okay. Now let's see the details of any of this particular application. So snow delivered to your door. There's this check stock function. Let's click on this. It shows 768 units. So let's see on the burp. So this was the request that was being sent to the stock URL. So this is a post request, and you could see in the stock API that this is being sent to stock.we like to shop.net 8080 product stock check product ID. So there's this URL, right? So SSRF is like you could easily identify an SSRF if you see that there's a URL that's being passed to it. So that's an identifier to it. So if you're able to pass a URL to any parameter, so you should always check for SSRF whether you could replace it with your own URL. If you have burp collaborator, you could add the burp collaborator URL. So if you don't have a public URL, or if you don't have a burp collaborator instance, because I think it comes with a pro version, so you could use this pipedream.com and you get a public URL for this. So if you send any request here, like if I go to this, so it would automatically show the request that's being sent on this particular website. So here you could see 7:58 a.m. So this was the test request. So client IP, what was being sent and all that. So that's that. So Burp Collaborator URL is basically the same. You add the URL there and the request is being sent to that. So yeah, let's come back to this. So what we had to do was we had to access the localhost admin. So let's try to access the admin here itself. Let's duplicate this. So if we try to access the admin here, let's see what it shows. Admin interface only available if logged in as administrator or if requested from loopback. So loopback is an interface which is the localhost interface. So that's the loopback interface. So if we are able to access it as http localhost/admin, then we would be able to log in or access the admin interface. So let's see that. So we have to access the admin interface at this. So let's copy this. I switched off the burp for a time being. So we already figured out that wherever you could pass a URL, and if you see that that URL is being accessed by the server, then that's the SSRF. You got the SSRF. So let's check whether it's vulnerable to that or not. We found that this stock API parameter was accepting a URL, and we are now sending it to the repeater, and we'll be passing this localhost admin URL here. So let's see this. So we saw the response coming here. Let me open this in the browser itself. Show response in browser. Copy. So you could see this is the admin panel. Users, administrator, delete, Carlos, delete, delete. So these are the three things. So we have to delete Carlos for this. So let's do this. So you could see there's this request being sent to Carlos. So if you click on delete, it should not work because we are not accessing it as an administrator, or we are not accessing it from the loopback URL. So let's see that. Admin interface only available. So we pass this admin/delete username equal to Carlos, but we had to do it through this only localhost. We could access that. So that's why we have to pass it here. Let me show you. Let's copy this. So what we are essentially doing is we are sending this post request through the internal server, and that internal server has this particular application running on the local host also. So since the admin interface is only available if you're logged in as an administrator or if you're requesting it from the local host. So loopback is basically the local host interface. So what we're doing is we are passing this URL to the server, and this server is trying to access the data from there. So once it's trying to access it, it's basically sending a HTTP request to that URL, and that's how we are able to do SSRF. So you could see we have solved the lab, and this is because we sent this delete request to this delete endpoint with the username Carlos, and this was being sent from the SSRF from the vulnerable server through SSRF. So hope you enjoyed this part. Let's come to the other thing, the SSRF and Google thing. So let me talk about this. So into the bog SSRF inside Google Production Network. That already sounds quite interesting because there's a sneak peek into Google Network, because SSRF allows you to look inside the network, scan the network, and all those things. So if you see this diagram, that's also on my slides. So this is the diagram which shows Borglet on something. So this is an internal interface. So it's an internal interface of Google Production Network, and this is a screenshot of that. So let's talk about this. So this person, he reported an excesses in Google Cache. So Google Cache is a tool that helps you securely embed arbitrary HTML or JavaScript in a web page. So he reported an excesses in March 2018, which was fixed in May 2018. After that was fixed, he was looking for the same on Google Sites. So Google Sites, it's a product from Google. So he found that there was this unpatched version of Google Cache but still being used on Google Sites. So he tried to find whether it was vulnerable to excesses or not. However, the excesses wasn't exploitable there. So he further mentioned that Google Cache parses the HTML, JavaScript, modifies it to remove any JavaScript sensitive content, etc. However, he found that remote JavaScript tag, that is the script tag with the source attribute, that was allowed. But the remote resource, he tried to get the JS file or the payload from his own server, but that wasn't allowed. Only URLs that were allowed were Google's URL, so google.com or gstatic.com and all those. So what the next step of action was that he created like Google, say there's a Google service called Google Cloud Service. So you could run your code there, you could host your code there. So he started that. He made a like it's like a VPS kind of thing, as you have on DigitalOcean, you have it on AWS. So it's a similar kind of thing. So he created a Google App Engine instance on Google Cloud Services and hosted a JavaScript file. He then used the URL of this JavaScript file on Google Sites as an external source and updated the Google Sites page. So this time the JavaScript was parsed successfully because the Google Cache server, they found that it was coming from Google's URL, so it was like successful. On the network instance, so Google App Engine is the whole, like you have the access to the terminal kind of thing, you have access to the logs and all that. So from wherever the IP is being, like the IP is trying to access the resource, you could see the network logs of that also. So we found that the request was coming from 10.x.x.201, which is a private network IP. So private network IPs are basically this. So 10.0.0.0 to 10.255.255.255. Then there's 172 range, and then there's the 192.168 range. So these three are the private IP ranges. So in most of the cases, if you are on a like private network, you would see these ranges. Even on your, maybe on your Wi-Fi, if you are connected to a Wi-Fi right now, you could check your IP and you would see that you might be on 192 or 172 or similar kind of URL IP. Sorry. So once he found that this was being accessed from a private IP, he was quite ecstatic that there's something interesting that might he find there. He used the private IP as, so what the next thing he did was he passed this private IP into the like script source tag. So in the script tag, he added the source attribute as this private IP, and then he like waited for the JavaScript external resource to load. He mentions that it took more than 30 seconds and he was about to quit that, but then he found that there was a 1 MB response that came. So earlier the error response used to be 1 KB, but this time it was 1 MB. So he was quite ecstatic and he mentions that there's 1 million bytes of information coming from an internal IP from Google internal network. I can tell you, I was expected at this point. So anyone would be, because Google is one of the biggest internet companies and it's like fairly secure. You don't find a lot of bugs, and if you're able to access the internal production network, that's a very big thing there. So the next thing he did was he did a responsible disclosure. He didn't went on to scan the network. He didn't went on to upload payloads and all that. He only made 3 requests in the network to confirm the vulnerability and immediately sent a report to Google VRP. It took them 2 days to fix the issues, and even though it was a Saturday, so probably they worked through the weekend to fix this. So you could easily understand how critical this was. So in the meantime, he couldn't help but test 2 or 3 more requests to try and pivot the SSRF into unrestricted file access or RC. So he just wanted to elevate the access, but before that he already reported to Google. So this is a diagram of how Borg looks like, or what is a Borg. So Borg is basically a orchestration framework. It's like predecessor to Kubernetes. So Google open sourced Kubernetes in 2014. So Borg is an internal large scale cluster management system. So clusters are basically like these are Docker containers which have applications. So they are not in total VPS or a EC2 instance. They are computers which have different containers running. So they might be like on the same computer or the same machine. They might have 10 different applications running, and all these would be on different containers. So containers are basically Docker applications. So Borg helps to manage and orchestrate all that. So the cluster management system is quite critical and quite important these days, as more and more services are moving to Dockerized thing. So he also mentions that he got this Borglet instance. So that the screenshot that I was showing earlier, it was a Borglet instance. And he also mentions on the hardware side, both servers were CPU which were 2.3 gigahertz with 72 cores, and the CPU usage was already 77%. They had 250 GB of RAM, and they had one hard drive each, which 2 TB, which was only 15 GB was used. So the data was not stored there; data was stored somewhere else. So he further mentions about the processing job and what other things he found there. Mostly there was Java code. It was not Python or C++. He mentions if you wonder what's Gmail system user, it's gmail at prod.google.com. So on May 12th, 2018, on Saturday, he reported it was automatically tried to P3 and escalated to P0 and then decreased later on to P1. So Google tends to keep most of its infrastructure available internally. So later on in the clarification part, Google awarded, like after awarding him $13,337, which is a like fancy number to award. They told that since it had unrestricted file access, but in most of the cases there were authentication internally also. So that's why they descalated it. So from P0 it was moved to P1. Nevertheless, it was quite an interesting read. Hope you enjoyed this. And do make sure you read this. I would add the link in the description. So you might find it quite interesting. So yeah, that's that. Hope you enjoyed this. And we are already close to 5,000. I plan to achieve that 5,000 subscriber mark by the end of this December. So yeah, if you like the video, make sure you press the like button, subscribe to the channel, press the bell icon, share it with your friends, peers, whomsoever you feel that they might get benefited out of it. Thanks a lot.